Hello and welcome to NASA's Kennedy Space Center in Florida for the pre-launch news conference for Boeing's Orbital Flight Test. This is Boeing's first flight of the CST-100 Starliner spacecraft to the International Space Station for NASA's Commercial Crew Program. I'm Marie Lewis with NASA Public Affairs, and we have some guests here to help us break down this mission. To my left is Kathy Lueders, Manager of NASA's Commercial Crew Program. John Mulholland, Vice President and Program Manager of Boeing's Commercial Crew Program. John Elbon, Chief Operating Officer of United Launch Alliance. Joel Montalbano, Deputy Manager of the International Space Station Program. Pat Forrester, Chief of the Astronaut Office at NASA's Johnson Space Center. And Will Ulrich, Launch Weather Officer with the U.S. Air Force's 45th Weather Squadron. We will take your questions in just a few minutes, but first we want to begin with some remarks from our guests. And Kathy, beginning with you.
So let me start off with the video.
Stand by for terminal count.
Stage 2, pressing for flight.
5, 4.
The purpose of the Commercial Crew Program is to return to our nation the capability to fly our astronauts to the International Space Station.
3, 2, 1.
There's just something about going to space that has always been special. So here's an opportunity to go back again in a different kind of craft.
Liftoff.
The Commercial Crew Program is revolutionary in a sense where it's going to provide us the opportunity to have more astronauts in space. It's going to further our ability for knowledge in a microgravity environment.
The fact that we're able to partner with commercial industries allows us to fulfill that mission to be explorers because we can work together.
There's a larger group of us that are dreaming that potentially could have a ride someday and be working in space.
Folks all over the world are going to be watching this because we're integrating new technologies that can make these spacecraft better and smarter and paving the way for the future.
So thank you for coming. I am really looking forward to the maiden voyage of the Boeing Starliner this Friday. This first mission will be our critical uncrewed demonstration mission designed to validate the end-to-end systems. I always say these demonstrations are a gift. They give us the opportunity to really see how the integrated system works through all the phases of flights. But also, more importantly, it helps us as a joint team figure out how we're going to work together and get ourselves ready for our crewed mission coming up. If we're blessed with great weather, I look forward to a mission early Friday morning and then coming to the International Space Station on Saturday. Our demonstration objectives will be accomplished with about a week on orbit, but we know ISS is a busy place. And we'll be working with Joel and Kirk and their team with them on the right time to return. I want to now let John go through the mission-specific objectives.
Kathy, thank you very much. It's just incredibly proud and humbling to be here this week. It's really a culmination of years of really hard work by the integrated NASA, Boeing, and ULA team. So this is really setting up just to be an incredible week. And I'll go to the next chart. If you look at the mission-specific flight objectives for this flight, starting with the first one, we'll obviously be poring over all of the spacecraft and launch vehicle data, going through every system, making sure that the spacecraft is solid in all of its subsystem areas. One of the real key things that we look at across the entire flight is all of the separation planes, starting with the launch vehicle separation, before that the ascent cover, but then when we get ready to re-enter and start deploying the forward heat shield, the base heat shield, all of those separation planes are very important. Make sure those are all solid and don't give us any trouble. Obviously, one of the key objectives is demonstrating the capability to rendezvous and dock with the International Space Station, evaluate the performance of the NASA docking system. As Kathy mentioned, we'll be up for about 7 days. when it's time to come home, it's actually a pretty quick trip from undocking to landing on the ground is only a little over 4 hours. So obviously we'll be evaluating all of the system parameters, making sure we get a good deorbit burn and evaluate all of the reentry and landing performance. And really as important as all of the spacecraft hardware systems and launch vehicle systems is the integrated performance of the launch, the flight, and the landing and recovery teams, and making sure that we have really sound processes and procedures, and the team is really ready to move forward and go into the crewed flight test. So we're looking, as Kathy mentioned, for an exciting Friday morning, 6:36 a.m. we should launch. All things go well, we'll be docking about 8:27 the following morning. We expect to open the hatch within 24 hours of when we dock. And then on the night, late the night of the 27th, we'll be undocking and as I mentioned, targeting 28th landing about 3:48 in the morning. So looking forward to a really short, quick, and successful mission. As far as the spacecraft goes, on the next chart, we are actually tracking no spacecraft anomalies right now. So the spacecraft is in really good shape. And I'll turn it over to John to talk about where we are at the launch vehicle, but really want to compliment John and his entire team. One of the first strategic decisions that we made in the commercial crew program was the selection of the Atlas V as our launch vehicle for its unprecedented safety and mission success record, and that team is just proving it every flight. So I'll turn it over to you, John. Thank you.
Yeah, thanks, John. I can tell you that the United Launch Alliance team is just thrilled to be a part of this. We launch a lot of important payloads to national security and other things, but there's just something special about launching humans, and to be a part of a program that's going to do that is a really big deal for us. And so we're honored to partner with Boeing and do that and really appreciate the opportunity. I want to talk just a little bit about the configuration of this Atlas rocket. So first of all, it's been, the Atlas family of rockets has just a storied history. The last time we launched a capsule with humans in it, though, was 56 years ago when Gordon Cooper was launched on Phase 7 in May of '63. And of course, John Glenn was launched on the first human orbital mission on an Atlas rocket in '62. There have been 661 Atlas launches in the family of Atlas vehicles. And this is the 81st launch of the current version of Atlas, the Atlas V. And so it's just got a long storied history. The configuration of this vehicle is N22, November 22. The N stands for no fairing. Most of our vehicles have either a 5-meter or 4-meter fairing, but the capsule, of course, flies without a fairing. The second 2 is 2 solid rocket boosters that are on the side of the vehicle to increase the lift capability. And then the last number in that N22 is 2 engines on the Centaur stage. It's a dual-engine Centaur. This is the first time a dual-engine Centaur has flown on the Atlas V vehicle. Previous versions of Atlas had dual-engine Centaurs, so we've flown that before, but not on an Atlas V. Some other things unique about this vehicle, if you look at it, there's an aero skirt that comes down from the capsule. That's to work the aerodynamics so that we don't create a lot of aeroacoustics as we go through that. Of course, we've added a crew access tower to the pad so we can, so John and his team can get to the hatch. And there's a system that's a part of Atlas called the Emergency Detection System for the crewed missions that will fly in a passive mode on this flight, but when we have crew on board, we'll be able to detect if there's any issues with the rocket and let the Starliner know so that an abort could be executed. And so those are kind of the new and unique things for that. As John mentioned, we had the launch readiness review this morning. We're tracking no significant issues with the launch vehicle either. And so we're looking forward to Friday morning and hearing the words, go Atlas, go Centaur, go Starliner. Thanks. Joel will talk now about Space Station.
All right, thank you, John. So welcome again to the pre-launch press briefing. On behalf of the International Space Station, I'd like to congratulate the Boeing team, United Launch Alliance team, and the Commercial Crew Program for all the work that's been done to get us to where we are today. sitting here at launch minus 3 days, talking about the final preparations for a vehicle, a test vehicle that eventually will take crew members to the International Space Station, puts a smile on all our faces, and we're excited and happy to be here. You know, next year, in November, we're going to celebrate 20 years of continuous presence on board the International Space Station. And the Boeing spacecraft, along with the SpaceX spacecraft, will join the Soyuz spacecraft in not only delivering humans to the International Space Station, but delivering science and research and science that we do today in low Earth orbit that benefits all of humanity here, that allows us as a test bed for exploration missions as we expand and go past low Earth orbit. So we're excited to be here. We're looking forward to this mission on Friday, and we're looking forward to future missions. With that, I'll hand it over to Pat.
Thanks, Joel. Well, first I want to say it's always a joy to come back to Kennedy Space Center in the Cape. And even after all these years, it never gets old. In fact, sometimes I think it gets better. So it's great to be here. It's also a privilege to be here to represent the entire astronaut corps. You know, we'll hear it said that there are no passengers or people, humans, on this particular launch, and I'll apologize in advance to Rosie. But all along, we're trained to look through the lens of the operator and of the astronaut. And so every step of the way, that has been our focus as we move toward this uncrewed launch. We consider this a dress rehearsal for CFT. And I don't think there's anybody in the office that as they've gone about their work, they haven't thought about Chris and Nicole and Mike. And for those of you that don't know those names, you might know them better as Fergie, Duke, and Spanky. But that's our crew for CFT. Now, I was having coffee with Sunny Williams this morning, and she reminded me that actually this vehicle here is the one that she will fly with Josh Cassada following CFT. And the last thing she said to me was, make sure you tell them to bring it back in good shape. So I think that we'll do that. The other thing that I had the chance to do is to communicate with our crew on orbit that is going to be on the receiving end of this historic flight. And they sent a quote down, and I think I just want to close with that. And to use their words, we are excited to welcome Rosie and the Boeing Starliner OF2 to the ISS as we continue ramping up our crewed launch operations from the Cape. We look forward to saying the words, Tally Starliner. Congratulations to all involved in bringing this milestone to fruition. Thanks.
Well, it's my honor to be here too, to play a small role in making sure that the weather is good for launch on Friday morning. And I have some fairly positive news to give you all today. But our mission at the 45th Weather Squadron here at Cape Canaveral, of course, is to ensure that everyone is safe during all launch operations here at the Cape. And part of that is evaluating 9 Lightning launch commitment criteria to ensure that the rocket is both safe from natural lightning, but also triggered lightning as well. And all things considered, things look pretty good, but we'll also have to be monitoring some constraints from the vehicle side of things, from the Atlas V vehicle, including wind constraints and temperature constraints, but they also look fairly good. So with that said, if we take a look at satellite imagery right now, it's a fairly disturbed weather pattern out there right now, but thank goodness today is Tuesday, right? And we still have several days until launch. So here we have this strong cold front out over the eastern Gulf of Mexico that's headed in our general direction. It's going to make for, a stormy afternoon here at the Cape, but that's okay because we have time to get this cold front out of here. And the cold front's expected to move through overnight. Our biggest concern behind the cold front for the next several days is a strong area of high pressure that's going to lead to increased winds for the next 3 to 4 days, all the way through Saturday. Tomorrow will be the windiest day, no doubt. 25 to 30 knot gusts will be common here at the Cape, so you're going to feel it. However, as we get into the day on Thursday and Friday, those winds will subside a little bit, closer to about 15 to 20 knots, which luckily is below any constraint that we need to be concerned with the Atlas vehicle. The dry air behind the front should help keep shower coverage to a minimum. So despite it looking so ominous right now, that front will clear down towards South Florida by week's end, and all we'll be looking for are a few isolated showers pushing in off the Atlantic waters. If one of those showers were to push on shore, say during the count, it could produce winds of around 25 to 30 knots, which is nearing some of those constraints that I was mentioning to you earlier. But the odds of having one of those isolated showers actually push over the launch pad right now appears very low, which is good news. So if we look at the launch forecast right now, again, notice the breezy east-northeast winds, 16 miles per hour. There'll be some gusts to 20 to 25 miles per hour. Temperatures will be cool behind that cold front that I mentioned earlier. Tomorrow will be the coolest day. It'll struggle to get out of the 50s and lower 60s here before temperatures slowly warm up for the rest of the week. But during the launch count with those onshore winds, our temperatures will be in the low 60s. Right now, we stand at a probability of violation, a 20% or 80% go, which is good news. Again, primarily concerned for the cumulus cloud rule, which will be monitoring those isolated showers and low-topped clouds pushing in off the Atlantic waters, but also, as I mentioned, the Atlas V constraints for winds. In case any of those showers push overhead and we get those gusts in excess of 25 knots, we'll be monitoring for that. Now, what you didn't see on satellite is yet another weather disturbance that is going to be approaching from the northwest over the weekend. And that system is going to cross the Gulf sometime during the day on Saturday into Sunday. That's going to lead to more inclement weather here in central Florida late in the day on Saturday and Sunday. So the good news is for Saturday morning, things look fairly benign. So if we take a look at the 24-hour delay forecast, we have, again, gusty east winds around 18 to 20 miles per hour. So again, below those constraints. Temperatures a few degrees warmer. But given the uncertainty with that second disturbance, we have a probability of violation right now of around 30% for similar rules that I mentioned earlier, including the cumulus cloud rule and the ground wind constraints. So all things considered, things are looking fairly good for the week's end. Only concerns, of course, as I mentioned before, any of those low top showers pushing in off the Atlantic waters leading to gusty winds. But one other note is that with a launch at 6:36 right now for Friday morning, that's about 30 minutes before sunrise, which should make for a very picturesque launch if I can provide you guys with some clear skies. So the good news is that with it being still dark near the surface, the sun will be coming up aloft, so we expect some very picturesque images to come out of Friday morning's launch. Saturday morning, I think it's a little bit earlier, if I'm not mistaken, it's around 6:15, correct? That might be a little bit too early to give us those picturesque images that we might be seeing Friday morning. So happy to be a part of the team, and thank you very much.
All right, thank you, Will, and thank you to each of our panel members. We do want to open it up for questions. We have several reporters on the phone, but we're going to start here in the room. So just a reminder to please raise your hand if you have a question. We have a microphone. Just wait for that to come to you, and then state your name and affiliation and to whom you are directing your question. So we'll start in the corner with Marcia.
Marcia Dunn, Associated Press, and if Kathy and John Mulholland could both answer. We really now seem to be on the cusp of launching people into space again from here. And do you feel an excitement building among your teams? I mean, it must be an emotional moment right now. And could you touch upon the significance of what you're about to do once crews start launching again from here?
You go first, then I'll go.
Yeah, I mean, it really is. It's incredibly inspirational. The team is really excited. I think it really peaked with the successful pad abort test about a month ago, and having the pad abort test rolling right into the final preparations of this spacecraft, looking at the significant progress we've made on the spacecraft build for crewed flight test, getting through the vast majority of all of the design verification work. So the team really has this huge sense of accomplishment, well earned, and is really ready. They've worked through pad abort, and that went well. They're really ready for a good uncrewed flight test. And then the first part of next year, if things go well on the uncrewed flight test, we'll be ready to go fly a crewed flight. Kathy?
Yeah, I mean, we have parts of our team that have been working to kind of put the pieces together to get to this mission over the last 6-7 years, right? And, huge accomplishment. I don't think sometimes when we're kind of in the midst of doing all the work, you don't step back and look at what you've accomplished. And when people see now the vehicles out there, the integrated vehicle on the pad, then it becomes real. You know, it really becomes real. All those discussions, all that hard work, all that verification, all that, you know, working through the analysis and making sure I's are dotted and T's are crossed is there in a closed-out vehicle ready to go fly. And so, you know, and within NASA, we tend to get through our flight readiness reviews, and it's almost like that's a huge accomplishment. But the reason us getting through that last week was that is the hurdle for us to then be able to go work through this and move into our missions. And our team sees this as a real step towards getting to our crewed flights. A huge ton of work, and we're really looking forward to the mission. And honestly, really looking forward to this great partnership that we've had with Boeing and ULA getting this mission done.
All right, just behind Marcia.
Yeah, hi, Bill Harwood, CBS News. For John Elbon, can you talk to us a little bit about the aeroskirt, and what would happen to the rocket if you didn't have the aeroskirt is one question. And for Joel, can you update us on the status of negotiations on Soyuz seats, additional Soyuz seats?
Yes, I'll take the first question. So as we worked through the wind tunnel testing early in development, we learned that without the aeroskirt, the shock waves attached near the base of the Centaur and created quite a bit of aeroacoustics noise there. And so the environments that existed were beyond what the hardware was qualified for. So by adding the aeroskirt, it smoothed that flow, and the waves that come off of the front of the rocket reattach below the Centaur. In that way, we don't get that acoustics noise, and we're in good shape. So that was the reason to put the aeroskirt on.
Is there a margin you've got it built into that for or how much above the load you expect that you can handle?
Yeah, so the avionics are qualified to certain environments, and we just need to make sure that the aerodynamics and the aero effects are such that those environments are enveloped by the qual testing that we've done. We're in good shape there.
Okay. On Soyuz seats, so as you're aware, we have had some fact-finding discussions with Roscosmos on some additional Soyuz seats. You know, when you have a new program coming on board, like the Commercial Crew Program, it makes sense to make sure we are looking at everything, working out the steps, and not putting anybody in the position where they feel rushed. And from an ISS program standpoint, it makes sense, and we are looking at the 2 additional Soyuz seats. Right now, we have the Soyuz seat. The last one that we've purchased is launching in April of 2020. And we're in, like I said, fact-finding discussions with Roscosmos on 1 to 2 additional seats.
We'll just keep working our way back on that side.
Thanks. Hi, Peter King with CBS News Radio. And I'm not sure if this question would be for Kathy or if it would be for John Mulholland, but I'm assuming that you guys are putting Rosie to work, and I'm just curious as to, what will be measured during her flight up, during her stay aboard or next to the station, and then on the way back down.
Absolutely. A number of accelerometers. We're measuring loads, moments on the crew. Incredibly important for us. We had an anthropomorphic test device also on the pad abort test, provided invaluable data for us as we really look to measure and understand crew loading on the land landing. Really happy with the performance from pad abort. One of the key parameters that, and Pat could probably explain it more, but you're looking at the moment of the neck on a crew on landing, and we were actually 10 times below requirement levels for that. So outstanding performance, but we really need to get additional data, and the uncrewed flight test is going to provide that for us. And obviously we named her Rosie, which is just really kind of pulling back from our legacy. And it's really inspirational, I think, to a lot of our workforce today. And we're really looking forward to the data she's going to provide and the benefits she'll make for our mission.
As in Rosie the Riveter?
Yes, sir.
Okay, thank you.
Emery?
Emery Kelly with Florida Today. Question for John again. Maybe a little in the weeds, but it's more of a data question. Obviously, you'll be getting data, in a sense, live streamed down to you, down to the ground. But how much of that data is sort of encapsulated in the spacecraft? In other words, how much of it are you going to get after the mission is over? And I guess how long does that review process take?
Yeah, absolutely. So a couple streams of data, some we call the OFI data. So that is downlinked through the mission, except for on periods when you have LOS. So a tremendous amount of data that we'll have downlinked and we'll be able to evaluate in near real time. And we've got thousands of parameters that we call developmental flight instrumentation. So all over the spacecraft, all types of data, thermal, accelerometers, strain gauges, thousands of different parameters. As soon as we land, within a few days, we'll be able to get that disk out of the spacecraft. We'll fly it back out here to Florida, start doing that detailed data review. Normally, our plan is to have a system-by-system data review within 2 weeks of landing.
We're going to do one more question in the room before we take a couple on the phone, and we will come back to the room because I know there's a lot more questions in here. So we'll go to the back corner.
Thanks. Hi, Irene Klotz with Aviation Week and Space Technology. For Kathy and also for Pat, when this program started off with the CCTCAP awards in 2014, I don't think anybody thought it would take 5 years to get to this point. But, NASA now plans to have that time and do a crewed landing mission on the moon. So I'm wondering what you've been able to learn from this program, managing this program so far, that you think has applications for this new effort, and why, aside from the early funding shortfalls and some of the technical issues, it's taken so long to get to this point. Thanks.
So I think building new spacecraft and developing hardware is really hard, right? And so I think folks say it looks like it's taken a long time, but I think when you go back and look at development history over time, I think this program's overall, I think, been doing a good job of laying out and meeting its obligations. Not exactly, like Irene, as you pointed out, to our original goal of, late 2017, but moving towards us being able to have crewed missions within the time frame that we'd like to have them. I think the thing I'm most proud of with Boeing and both of our commercial crew providers is, as they found issues, they didn't shortcut. Right? And so we all have understood that our mission, for us to fly crew, we have to fly crew safely. It doesn't do any good to do it in a way that we're both not going to be comfortable flying our crews on these vehicles. So I think the Boeing folks, when we came in, they laid out their plan, and as they worked through issues, they didn't have that schedule pressure to be able to say, we're not going to do the right thing independent of what that meant from a schedule perspective. And so I think we've been working to get here as fast as we can. I appreciate what Joel is saying. Joel's saying, hey, we understand getting a new spacecraft online, getting new systems, developing and integrating and certifying commercial vehicles is hard, and so we need to make sure you guys have the time to do it right. And so I'm very proud of this team that they've been doing it right. We have been working with the lander folks to talk about, making sure you have your requirements up front, working through that. Where in the process can you gauge and make progress along the way so you can take learning from us. And so that's an interactive discussion with us and applying our lessons learned to the new programs coming forward. It doesn't hurt to have a very competitive goal. I think that is always good, to have a very, a goal that you're out there and trying to achieve, trying to get to crew services as quickly as possible. What's not acceptable is meeting that goal unsafely, and that is something that this team has not done.
Thanks, Kathy. Kathy. We do want to go to the phone for a couple questions. The first one is Jim Siegel from Spaceflight Insider. Jim, can you hear us?
Yes, I can.
All right, please go ahead with your question and to whom you're directing it to.
I'm not sure who this goes to, but I have a question about the process of landing the spacecraft that's going to be done on land with the air cushions. So I'm interested in a comparison from a human factors point of view of that kind of landing versus the landing, let's say, of the Soyuz, which is also on land, versus a SpaceX or other capsule that has been landing in water. So is the one that's being used for Starliner easier on the body, harder on the body, and in what way?
Let's see. I guess I'll start this. John Mulholland. The real benefit, there's a lot of benefits of landing on land. One of the main benefits is the stability and the ability for the landing system to absorb the loads on the crew and on the spacecraft. Our spacecraft has to be certified to land on land or in the water. If we end up in an abort uncrewed flight missions, we will land safely in the water. The difficulty in water landing is a lot of variables that you have to face. You're landing in salt water, but landing into a wave can add significant amount of loads into the capsule. So the real benefit of landing on land, it helps on reusability. You have lower crew loading. You get a real benefit out of those the landing airbags that we have. They're really two airbags in one. So the outer airbags, when you land and they compress, the relief valve blows. The air goes out of that outer airbag, absorbs a lot of that landing energy. I mentioned a little bit of the data on pad abort on how benign that load was to the crew. So a lot of benefits, we think, with our landing system and landing on land, although in the event of abort, we'll provide a safe landing with that same system in the ocean.
All right, thank you, John. The next question on the phone is from Dave Mosher with Business Insider. Dave, are you there?
Yes, I'm here. Thank you for doing this press conference. I wanted to follow up on an earlier question about the Roscosmos flights, those two new seats you want to get. I understand there's a years-long lag from when you order a Soyuz flight to when it's actually delivered. So what would the shortest gap be between that final April 2020 flight that's already on the books and any of these new seats if a deal is reached? I guess what I'm asking is, are there already missions on Soyuz that NASA could sort of co-opt seats from, or would you have to wait for new spacecraft to be delivered? Thank you.
Okay, so again, the nearest Soyuz that we're looking at is the fall of 2020. That spacecraft was already being built, and so we would work with Roscosmos for a seat on that spacecraft that's already being built. We would do the same thing for if we decide to purchase the Soyuz in spring of 21. Again, the Roscosmos is continuing to build 2 Soyuz a year, and we're negotiating, or we would do negotiation with them on assessing that third seat on that. So they'd have 2 cosmonauts and then 1 U.S. astronaut.
All right, thank you, Joel. We will take one more question on the phone, and then we're going to come back here in the room. And our third question on the phone is from Eric Berger from Ars Technica. Eric, are you there?
Yes, I am. Thank you very much. I have a couple questions. First of all, for John, congratulations. Could you tell me how close the OFT vehicle is to the CFT Starliner? Are they essentially the same spacecraft? And then secondly, for Kathy, what is the shortest delta you could imagine between a successful OFT and then getting the CFT mission off the ground? Thank you very much.
It's really important for us from a systems perspective. It's nearly identical. About the only thing that we will not have on the uncrewed flight is what we call the suit fan package. So we've got a system that will provide emergency oxygen to the crew in case you have a cabin leak. Obviously, without a breathing astronaut on board, you wouldn't be able to check out that system. But other than that, the systems are nearly identical. The only other thing that we haven't enabled for the uncrewed flight test is an in-flight abort, as mentioned earlier. Other than that, systems are nearly identical. Kathy?
So, I mean, I think there's a couple of things that drive the duration. Obviously, most important is the crewed flight test schedule, right? So we'd have to work through that. We need to make sure as we're getting the vehicle down, we need to understand, John talked before about all the data that's there and working through that and making sure we're rolling that into our final verification. We actually have developed our next round of closeout and making sure we got our final certification efforts in place to line up when the crewed flight test vehicle is ready to go. So John and I are still working through those schedules and finalizing those. Obviously, getting this vehicle and having this demonstration mission is going to be a key part of that schedule.
All right, let's come back here in the room. Ken, in the front row.
Hi, thank you. Ken Kramer, Space Up Close and Rocket STEM. For John, I'm wondering, you're talking about recycling these spacecraft, and this one, as Pat said, would go to SUNY. What is the quickest time? What is the time for refurbishment, and what do you have to do to get it ready?
And nominal scheduled time for turnaround would be about 4.5 months in the factory. Like I said, largely it's reusable. The new pieces that would come in every flight, we'd have a new ascent cover, a new forward heat shield, a new base heat shield. Obviously, those parts of the thermal protection system would be new every flight. Essentially, the rest of it is fully reusable. And so we've got a methodical series of inspection procedures. Then we'll do all of our leak tests and again, just start closing out the vehicle. Very similar to what we did over the last couple of months before we rolled out to the pad.
Inside the capsule? You don't have much to do then?
Very little inside the capsule. So obviously we'll do inspections. So we've got a number of routine structural and avionics inspections, but it's really almost a near duplication of that acceptance test procedure that we ran prior to shipping the uncrewed flight vehicle over to ULA. So it's those procedures, those timelines have already been established and tested.
Thank you.
Okay, second row with the white shirt.
Jeff Faust of Space News. For John Mulholland, you mentioned the pad abort test. I want to get an update on how the data review from that is going and if any of the results have fed into planning for either orbital flight test or crew flight test. And then second for you or for Joel, besides Rosie, what cargo is going up to the space station on the OFT mission?
Yeah, absolutely. So the pad abort test data review has been really successful. So the teams have worked through. There's obviously a lot of key parameters that we wanted to go look at. And I mentioned one of the objectives here on the uncrewed flight test was looking at all the separation planes. That's always essential. And this orbital flight test is obviously the last opportunity we're going to have to go test those. Those are all 100% successful from a separation standpoint. I did mention the one crew loading data point that we had. The other thing that we looked at was shock in our system, all the shocks from all the pyrotechnic devices, and they were all right on top of pretest predictions. And then the final area that was really important for us to go look at was guidance, navigation, and control performance, and it was outstanding. It was right on top of pretest predictions. So, the team is just really proud of the pad abort test. Obviously, we had 2 chutes instead of 3 because of an error that we had in the final rigging that we've gone and fully addressed, and the team's ready to go fly.
From a cargo standpoint, we're flying 270 kilograms of ISS cargo on this mission. The majority of it is food, but we also have some crew clothing and some radiation monitoring equipment.
All right. Chris, in the black shirt.
Thanks, Chris Gebhardt with NASA Spaceflight. I want to go back to the Atlas for this mission because it's not just the configuration, it's also flying a different profile. I was wondering if you could talk to us about how that flight profile is different from the others, and specifically, why is Starliner being dropped off in a suborbital trajectory, and what is that final number, like 98 nautical miles by what? Basically, how far into the atmosphere is that trajectory still that Starliner has to make up for?
Yeah, so the part of the main reason for using the dual-engine Centaur is to flatten out the trajectory such that we can enable safe aborts if that should be necessary. There's a couple of things that happen there. Without a lofted trajectory, the G-loads are lower as the spacecraft re-enters from a lower altitude. And so that's important. And also we need to keep out of the blackout zones in the North Atlantic, and that flattened trajectory allows that to happen. It is suborbital when we release it. John, maybe you have the numbers. It's like 80 by 40. Those may not be precise. We can get you those precise numbers. And then the OMAC engines from Starliner will circularize that orbit from that point on. Do you know the exact numbers for the orbital?
It's, I think it's 90 by 39.
All right. In the front, in the pink.
So I just have two quick questions. Chelsea Goad with Space.com. My first question is just if you could just walk us through Starliner's journey, from the ground to the International Space Station, how many orbits it will complete. And then secondly, during a press conference, I believe it was last week, someone mentioned that there may be holiday presents potentially on board the spacecraft, and I just would like to inquire a bit more about that. Thank you.
Yeah. Reveal all the presents, so, or they're not presents.
Well, let's see. The teams literally spent, and Kathy kind of went through it, but the teams literally spent years building spacecraft. They actually, this is the last spacecraft that they've built, because we built spacecraft 1 for Paderborn. They built spacecraft 2, which will be the first crewed flight test, and shipped it out to El Segundo for about a 4.5-month campaign. Before all of that, we built a structural test article. But so spacecraft 3, the team really did a good job. Absorbed a lot of the learning on building of the other spacecraft, and this one went really well. About a month ago, they completed the last acceptance test of that spacecraft. We rolled over to the VIF, and we've been doing final spacecraft closeout as ULA was preparing the launch vehicle. And so the team's really excited. They closed when they did their final closeout on Saturday. It was a really special moment for the team because all spacecraft work was completed in the VIF on Saturday, and all systems are checking out good, and so we're really excited about that. As I mentioned, one of the key focus areas that we have on commercial crews, since we're the transportation platform, is we want to get to our destination as soon as we can, and then when it's time to leave our destination, we want to get to the ground as soon as we can. Get there and get there safely and get your mission completed. So we'll be docking about 25 hours after launch. So it is what's called a Flight Day 2 rendezvous, but barely into the second day. So not a lot of orbits. And along the way, we'll be doing a number of what we call demonstrations. So as we incrementally get closer to the space station, we've got a number of checkouts that we have on our autonomous rendezvous and docking system so that the ground can monitor and ensure that all those systems are working appropriately and that we maintain the protection for the space station that's required. When it's time to come home, I think I mentioned earlier, it's from undocking to the ground. It's only about 4 hours. So we'll undock. We'll do system checkout on all the thrusters, and from the time we do the deorbit burn to the time we land out in the desert, it's about 40 minutes. So it's really quick when it's time to come home.
Thanks, John. We've got time for a couple more questions. We're going to go over here.
John McGill with Wyandotte Cable and News. I believe this question's for Joel. What issues do you go over with our international partners when you bring a new craft to the space station?
And so we review, for this mission, what we review is the close-in or the proximity operations when the vehicle is coming near and departing the International Space Station. So we go through the trajectory operations. We go through any atmosphere changes that you'll have when you bring a new vehicle with to the International Space Station. So there's a different set of safety requirements, a set of mission requirements, a set of interface requirements, and we review all that with the international partners, and it's a lot of work. Once we switch over to crewed vehicles, we'll start incorporating more of the launch vehicle into those discussions. We already have done some of that. We've done some preliminary discussions with both the launch vehicles and the landing operations with the international partners, but those are the type of items we discuss with them.
Okay, next question in the stripes here.
Don Haladiak, CBC Radio. Question for Pat. Will the crew have any ability to take control of the spacecraft if there's any anomalies with the docking?
I assume you're talking about the ISS crew. They will not. We have trained the crew for this, and they'll be watching. Most of that, the data information will be available on the ground and not necessarily on board the ISS, but they are trained as we call them visiting vehicle officers, VV1 and VV2. That's Jessica Meir and Christina Cook.
Thanks, Pat. The question here, just next to Bill.
Hi, Stephen Clark from Spaceflight Now. I was wondering if John Elbon or Mr. Mulholland can talk about launch dates available after December 20th. What do you have on the range, and what do you have in terms after that in terms of ISS phasing, your availability for launch dates, and also any limitations on how many attempts you can make before you have to roll back to the VIF to do any servicing on the spacecraft or the vehicle?
Let's see, I'll start out from a spacecraft standpoint. So available launch days as we work with the International Space Station program and our ability to have the performance to get there. So we have the 20th, the 21st, and the 23rd on the range. Available days from a capability to get to the International Space Station. We don't have the 23rd, but we have the 25th through the 28th. And then we do not have capability on the 29th, but then we got 3 days after that. So we're really set up in the month of December if for some reason we can't get off on the 20th. Now, you've got to factor in if you did scrub, where you scrub into the count, because obviously once you have a certain number of temps, certain amount of usage of the propellant before we'd have to, or ULA would have to bring in some additional propellant. But had a lot of discussions, obviously, with NASA ULA and the range and the International Space Station program. But everyone is very supportive that we're going to do everything we can, even working over the holiday break to make sure we successfully complete this mission. And John, I don't know if you want to go through them.
Yeah, just add a little bit about the cryo consumables. This mission has longer built-in holds in our count than is typical, and so we have, and that's done to accommodate loading the crew when it's a crewed mission. And so there's more time where we have boil off. And so depending on when we would decide to scrub in the count, that could be a bigger problem or lesser of a problem, depending on how much cryo we boiled off. So it kind of depends. You know, we'll have to look, if we do have a scrub, we'll have to look at why we scrubbed, how much work we have to do to fix whatever the reason was, and then where we ended up with consumables and how many attempts we can get with the consumables that are left before we have to replenish. But as John mentioned, we're set up for the 20th, 21st, and 23rd at the moment, and we'll work our way through that.
All right, thanks, John. I think we have time for one more question. Bill, I know it looked like you had a follow-up.
Again, you know, reporters were always asking about when are they going to launch the CFT mission, obviously, but that really depends on how it phases into the Atlas launch schedule. I know you got Solar Orbiter, which is a planetary window. You got a couple of military flights in March and April, I think. How tough is it going to be to phase Starliner in to a pretty busy manifest early next year?
So we do have a busy manifest coming up this year. We have, in general, a launch a month. We do have Starliner worked into the manifest as it's set now. You want to talk about the date for that, John?
Yeah, we're still looking. I think there's a couple areas we could fit it on the manifest in that first part of the year. We wanted to really stay away from any announcement of a crewed flight test launch date until we successfully complete OFT and make sure that we're ready to lock in a launch date.
Yeah, so we have a baseline we're working to, and we'll see how we adjust that. As you mentioned, we have Solar Orbiter, Mars 2020. Those are planetary missions that kind of lock in. And then there are some other, those are really cool missions too, by the way, some pretty special NASA missions that are going to happen this year. And then some other Department of Defense payloads. But we'll work through that. The team is working lots of iterations and options, and we'll figure out how to work through.
All right, thank you to the Johns. That's about all the time we have today, so thank you very much for your questions. Thank you to each of our guests for your time answering them. As a reminder, the launch is at 6:36 Friday morning, that's Eastern Time, and our live launch coverage starts on NASA TV starting at 5:30 Eastern. Thank you so much, and for more information, visit nasa.gov/commercial crew.